Good day, hello everyone. We're going to see how can we export log data to a spreadsheet. So let's start opening a GeolOil already process I have here. File, open GeolOil. We have the aliases to start opening the aliases, how were they paired with the mnemonics. And let's have a look on the display. Step 1, Step 2, Step 3, and Step 4. Okay, we have 5 tracks: lithology, resistivity, pore space, permeability, and water saturations. Particularly in the pore space, permeability, and water saturation tracks, we have core data measured from the lab. So these blue dots are porosities measured from the laboratory, and here we have the continuous curve computed with log equations. We have a reasonable match. And we also have permeability core data measured. These are the magenta dots, the points. And we have computed curve for absolute permeability and also permeability to the oil, that is the green filling and the green curve, and permeability to the water, that is the blue and the blue filling on the curve. And we have also water saturations. So we have the green, it stands for oil. The blue filling stands for free water or mobile water. And the gray is the irreducible water saturation. That is water that you don't expect to move. And here we have the points for water saturation measured in the lab. Let me move this to the left, and we follow this one. I want to export core data and log data to build a correlation of permeability as function of porosity and volume of shale. You go to two-dimensional sets. Well, this is already processed. Let me remove this one and follow the work from scratch. Remove this one. So I'm going to remove, this is already done, so I'm going to follow these steps. Okay, let's pick a color you choose, any one. And active. Title for that, maybe something like the one to the right. K horizontal, and the title for that, export porosity for pen and log Vshale to Excel. Okay, now open and follow the same steps. Here we have the variables. So in cross plots, you will see have an x-axis and y-axis. If you want to use color in 3 dimensions, maybe several properties. We call it Z1, Z2, C3, and so forth. So this can be colored. And this T1 may be transparencies. And filter. We have a collection of 5 stratigraphic filters or 5 generic filters, F1, F2, and so forth. Deselect and start assigning. So I want here, assign X to core porosity. So we identify here, this is X, and this is core porosity. So I take it from here and drag it here. That's it, that's X. This is because I want porosities as a regressor or predictor variable. And now Y. Y will be here, permeability, core permeability. So we have to identify Y, and we drag and identify by here core permeability. The alias is K horizontal maximum from core. We can put several properties and filters. Now let's suppose you want to use a color X, Y, and color, or you can use a 3-dimensional correlation. Instead of X, Y, have a permeability as a function of porosity and also Vshale. That is one function we're going to explore. So let's catch this one, Z1, and assign to Vshale final, to this one. Final Vshale. Okay, so we have core porosity, we have core permeability, and Vshale from log. So we have core porosity points, permeability points, and Vshale is the black curve. To estimate Vshale is not particularly difficult and very accessible. That's why we're using that as a predictor variable or regressor variable. Continue with 2-dimensional sets. Open that. And filters. We have 2 stratigraphic filters. This one is the study flag. Produce a flag for the study, the zone we're going to study. second filter will be, we want to exclude both hole problems. So we see the caliper and we want to exclude that. We can be more explicit with caliper. We can put here a generic filter. We don't want the caliper to extend too much because it will cause borehole problems, washouts and that stuff. The second step is to assign the filters. Let's follow this guide. These are the values, the depths, it always appears. We have X, which is core porosity. This is the alias and the mnemonic. Core permeability, this is the mnemonic and the alias. And Z1 for multidimensional correlations or colors, it is Vshale. And the filters. Study zone, stratigraphic filter, and a generic filter. Let's start with the caliper here. I'm going to make a plot. If we go to the bottom, you see the caliper. Caliper from this value to the right, they are marked as orange, light orange, associated with bad borehole. We want to accept the data when we don't have problem with the caliper. The caliper has to be this value, like 9.0 or less. Something like that here, where we have 8.9. So we want to switch by caliper, and we are going to accept calipers between 0 and 8.9. Bad borehole, it was already processed. It was in upscalings. It was a filter. You want bad borehole with value of 1. And zonation, you have here bad borehole, that is a flag, and you filter by borehole. So how do you see that? In the sums, bad borehole. Bad borehole, it searches for borehole, it searches an interval, these are intervals, and we want to detect those. And when you run that, and you see the result, bad borehole, this one, so 0 is no problem, but we have some boreholes here, bad borehole there, and towards the bottom. Those are the bad boreholes, these ones. This one, 1940. Let's keep on going. Okay, bad borehole is a filter. You saw that we are using 1 when there is a bad borehole condition. So we have to embrace good values for the borehole. So if 1 is a bad borehole, so we'll have values less than 1 for good boreholes. Less than 1 is something like that, from at most 0.9, maybe from minus infinite to 0.9. That will capture good boreholes, 0.9. Likewise, we have a filter for the study zone. Let me show you how was it produced. You go to display, stratigraphy. Study zone, this one. So we want to filter for the study zone. This is a formation from this top and this base. So it was filtered this way. The scaling list, study zone, open that one, replace with 1, no cutoffs, zonation, study zone, that is the string related to that, study zone, and we're filtered by formations, and we want to produce a detected curve, study zone flag. Produces a curve for that, this one. So 1 means the zone under study and 0 is outside. Continue with the filtering. So I want to filter for the study zone. So I have to capture 1. 1 means that is the zone I want to study. So to capture 1, I can put an interval to embrace that, maybe something like 0.9 to 1.2. I don't want to place any filters on the variables itself. You can put any filters on any variable, x, y, and z1. Let's start removing this option. Calculate data sets, it will turn on this tab. These are core values, so there are core values in very few points, these ones. And Vshale is a continuous curve from the log. So we have the core permeability and a continuous Vshale from the log curve. So this will be based for our sport. And also we have the filters, the 2 stratigraphic filters, F1 and F2, and the generic filter. You remember that generic filter was the caliper. We wanted to accept the borehole when the caliper is lower than 8.9, so that's why you see values like here, all of them below 8.9. And the filter is 1 and 0 for bad borehole. We want to reject bad boreholes. This is your data. Let me show you the points. Okay, this is why we have so many minus 999.25, because core data is available not everywhere. For instance, this is 1692. There's not core data here. And the first point start here in 1694. This is your first point. That one, 0.219, right? This value. So we don't have core data everywhere, but we have shale everywhere. The shale core is a continuous core. I don't really want to export the minus 999 values to Excel, those rows, because how can we process that? That means there is no information. So let's go to filters, and I can say, well, remove the minus 999. Then I have a clean list. This one, this select. Core porosity, core permeability, continuous Vshale, and the filters. Maybe you are not interested in the filters. Once you have process, you are happy with the filtering process, you can remove those. Compute, calculate data, set results, and that's it. And this is the set that you're going to export to Excel. But let's go more. Let's suppose that for some reason you want to do some manual removes. So let's say, for instance, I don't want these values. So I highlight that from 1853 to 1859. You hit remove selected depths. And maybe you can continue. I don't like this. You can do manual removals. You can guide here with the log plot. You can do manual removals or undo the results, these ones. Now we can export that to Excel. Let's see how to do that. So you simply say export Excel comma separated values. You select a file name, video example, something like that. You create a comma separated value, result. And let's go to Excel and see the export. So you go to Excel, browse, and select for all files, because there is a comma separated file. Open this one. We have your three columns: depths, core porosity, and core permeability. That is what we asked. Now, once you have that, well, you are done. So let's make some computation in Excel. Let's open this file, which is already fully processed. So we have here the columns, the depths, the X, which is core porosity, the Y, you remember is core permeability, and the continuous Vshale curve from the log. Let's suppose we want to make an equation out of this. You go to GeolOil, and I want to fit an equation. Something like this one, equation 2. So we want something like this. We want to forecast the permeability as a function of porosity and the continuous Vshale. There are some parameters, which is this one, and this one. To do that, we have this equation. If you take logarithms, natural logarithms, you will have a linear expression. Going back to Excel, so we have made the transformation, the logarithms, and you take a full correlation on this, and you see the relationship. These are partial cross plots in Excel, logarithm permeability and logarithm porosity, and partial cross plot on logarithm permeability and Vshale. So you see a one-to-one relationship, increases. Vshale increases, permeability decreases. You see this in the results. This one, you see here is permeability, and this is porosity. So generally speaking, you have red to reds, blue to blues, and green to green. So more or less, if we have a trend to a high permeability, that is a trend for high porosity as well. High porosity with high permeability. Likewise, we have a reverse effect with Vshale. Red values of permeability are related to blue and green values of Vshale. High values of Vshale are related to low permeability, an inverse relationship. And this is what you see in these cases. So once you take the transform, you return the variables. So these are the coefficients. And you enter those coefficients into the equation in GeolOil. And that's it. Those are the values. These are the coefficients you have to enter in GeolOil. This one, 725, 1.68, and 1.62. Once you have that, you can compute your continuous equation, the correction for permeability as a function of core porosity and Vshale. And then the core porosity will be replaced by a log curve, the one already estimated, this one. Hover the mouse over there and you see a help on the curve. Effective porosity and Vshale, and that's it, you calculate. And then you can make a full display on that, and this is the display. That will reproduce the curve of absolute permeability. Well, this is all for now. Have a wonderful rest of the day.